Right on. So I want to talk about reaction types today. This kind of assumes that you have some understanding of some chemical reactions and how to balance chemical reactions. We'll do a little bit of that today as well. We're also going to talk about ions. And don't forget that ions are atoms or groups of atoms that have either gained or lost electrons. So, synthesis. Let me switch to a pen. Thank you for your patience today. We got synthesis. Boom. The general form looks like something like this. Well, this is also known as AKA combination reactions. So the general form goes like this. You start with substance A and you react it with substance B and you make a new substance C. That's pretty straightforward. Example, you could take nitrogen gas, two nitrogens bonded covalently together, plus some hydrogen gas, two hydrogens bonded covalently together, and you get a reaction where you make a substance called ammonia, which is NH3. This is a gas where you could dissolve it in water, and you can even use it as a fertilizer. This is called the Haber process, and if Mr. Haber hadn't figured this out, we wouldn't be eating as much food as we do. But this isn't balanced right now, so what I'm going to do is I'm going to look at my nitrogens, and I'll put a 2 there to balance out my nitrogens, which gives me 6 hydrogens. And I'll put 3 hydrogens there, and that's all balanced out. And that is a synthesis chemical reaction. Up next, we have what's called decomposition. I'm not going to write all this out, but decomposition. Check. Something falls apart, so you just take out substance C, for example, and it would just turn into substance A and substance B. It's kind of like the opposite of synthesis. Go figure. So let's take a substance like this. This is an ionic compound, KClO3. If you looked it up, it'd be called potassium chlorate, and that is a solid, and that stuff will decompose into KCl, in this case a solid, white material, and O2, the gas. So if you need a little O2 or a little KCl, you could do it that way. Let's balance out this chemical reaction. Look at my potassiums, they're looking fine. My chlorines are looking fine. But I got a disbalance here in my oxygen. So what I'm going to do is I'll do like lowest common denominator type of situation. And that I got to put a 2 here now. And then I got to put a 2 over there. And that's a balanced chemical reaction for the decomposition of potassium chlorate. Bada boom. Rolling right along. We have another one called combustion. Oops. Get my pen colors figured out. Combustion. Things combust. Pardon my penmanship. This is the freest software I could find. Combustion. Oop. Well, something, and some latency here, I apologize. Something plus typically oxygen makes fire. That is a combustion reaction. Now for us in the Earth's atmosphere, most of the combustion reactions that we deal with oxygen, but there are some that don't. Those are interesting reactions. But for instance, if you take a substance called propane, which is a hydrocarbon, it contains carbons and hydrogens, and that's it. It's a gas. You pressurize it, it's a liquid, and that's why a propane tank sloshes around like it does. But and then I got a little bit of this stuff here, which is atmospheric oxygen, readily available on any 4th of July. And what you do is you take that propane and react it with the oxygen to make 2 new substances, CO2, or carbon dioxide gas, and you guessed it, H2O. In this case, also a gas, because this is an exothermic chemical reaction. It generates heat, so those products come out flying apart as high energy gas molecules. So this one's not balanced. And I'll take a look at my carbons first, and I'll put a big 3 there. And now I'll take a look at my oxygens. And on this side total, I'm going to end up with 10 oxygens. So I'll just put a 5. Well, hold on, I skipped a step. I usually go left to right. So I look at my my carbons, they're fine now. My hydrogens, there's 4 here and, excuse me, 8 here and 2 there. So I'll do a 4 there. Now that gives me 10 oxygens on this side, so I have to put a 5 there. And there you go, that's the combustion of propane. Important reaction for cooking hot dogs. Let's go here. Next up, single displacement. This is good. Single D. I'll just write sing D so we can truck along with this. Check. Imagine, if you will, you got a substance A and another compound, BX. And what's going to happen is there's going to be a displacement. And what's going to happen is A is going to displace B. And we will get AX plus B. So it's like B and X were dancing together. And A showed up and X said, hey, I'm going to dance with A. And now one atom or group of atoms, it could be a polyatomic ion, displaced another atom or group of atoms. Example, we've got zinc, the solid, and I can react it with a substance called hydrogen bromide, which I may be wrong, but that could be bromic acid, and that would be dissolved in water. And I would make a new compound. In this case, zinc would displace hydrogen due to their placement on what's called the reaction series, and I would get a compound called zinc bromide and a little bit of this stuff here, hydrogen gas. So if you need a little rocket fuel and you've got some of these compounds kicking around, zinc and hydrogen bromide, you can make some hydrogen gas. But once again, we're not balanced out. This one's pretty straightforward. I can find my mouse here. And you just need a 2 right there. Done. Single displacement. Next up, I'm going to move my little pad here. I got to get more ergonomic. Here we go. Double D. This is a double displacement reaction. Double D. Okie doke. It's like a single displacement, but it happens twice. So we've got a substance AX and another substance BY, and they are chilling out until you combine them, and we get a displacement, 2 of them, where A is now bonded with Y, and B is now bonded with X. So like B and A displaced each other. Double displacement. Example of which? Lithium phosphate. LiPo4, 3 lithiums. This is aqueous, dissolved in water, plus BaCl2, barium chloride, that's aqueous as well, are going to react together. And they are going to form, displacing each other. The lithium will displace the barium. They're going to switch places on this one. So you're going to get lithium chloride, which is a solid. Check. And then you're also going to get a substance called barium phosphate. That's a polyatomic ion, and there's 2 of them. This is dissolved in water. There you go. They switched out. How do you like them apples? Well, we got to balance them, those apples. And if I do the math, well, we got 3 lithiums there. I got 1 lithium there. I'll put a big 3 there. And I got 1 phosphate here, PO4, but I've got 2 over there. What? I'll put a 2 here. Kind of screwed that up. I guess I'm going to have to put a 6 here. Alrighty. So let me go. Lithium. I got 6 lithiums, 6 lithiums. Check. I've got 2 phosphates, 2 phosphates. Checked. Let's take a look at the barium. I got 1 barium there, and I got 3 bariums there, and I'll put a 3 there, and that also balances out my chlorine. So I've got 6 chlorines here, 6 chlorines there, and I've balanced out my double displacement reaction. I ran out of room at the bottom here. I gotta make it taller next time. The last thing I need to talk about, and this one's gonna take very long, is what's called a redox reaction. A redox reaction is when one element loses electrons, and then one element gains electrons. So in a redox reaction, there's an exchange of electrons. One element loses electrons and one element gains electrons. And there's an easy way to learn this and remember this, and it goes like this. Leo says grr. Leo, the lion, says grr. And this is this process here and this process here. Leo says grr. Lose electrons oxidized, gains electrons reduced. Lose electrons oxidized, gains electrons reduced. And that's why they call it reduction. We've got reduction, which is the gaining of electrons, and oxidation, which is the loss of electrons. So redox reactions, there's an exchange of reactions. One element loses them, and the other element gains them. So that's the basics of it. So then how do you know if a reaction's a redox reaction? That one's kind of tricky because then you got to like look at the reaction. So what I did is, I'll post a link to this too. Let me tab up. Oh, there we go. Boom. Oxidation reduction, a reaction where one element loses electrons from reactants to products, and another element gains electrons reduced from reactants to products. So it's just the list of rules. Single displacement and combustion reactions are always redox. So in both of those reactions types, there's always an exchange of electrons. Reactions involving free elements as either reactants or products are also redox, right? So I guess if I look back, let me tab back to my drawing here. If I look at like, if I look at nitrogen and hydrogen there, well, these are free elements, so that has to be that's a redox reaction right there. There's an exchange of reactions right there. There's an exchange of reactants right there in my synthesis reaction. Let's go. Double displacement reactions are never redox reaction. Oh, I skipped one. Reactions involving free element. No, I did that one. Double displacement reactions are never redox. The charges of the ions do not change when they switch. So let's take a look at that one. I can look back at my sample reaction here, and I go, well, decomposition. I bet that's redox too. Yeah, because there's a free element there. Like right now, that's the opposite, right? So like if you start with a free element in a single displacement reaction, and there's got to be an exchange of electrons. But in a decomposition reaction, if you're ending up with a free element and you didn't start with one, then you got to figure it's the inverse. Yeah, it's also a redox reaction. There's combustion. That's a redox reaction. Let's look at which one were we doing? I lost my train of thought there. I babbled away. Yeah, synthesis. Decomposition reactions, yeah. Now, double displacement are never. All right, that's where we ended up. Thanks for your patience, guys. I appreciate this. Down here somewhere. Redox, redox, redox. Yeah, okay, found it. Double displacement. Let's take a look at that one. Lithium. Lithium here is +1, right? Phosphate is -3. Barium is +1. Actually, barium in this case is +2, I'm sorry. And chlorine's -1, right? So there we go. But if I look over here, lithium is +1, chlorine's -1, and phosphate is still -3, and barium's still +2. So there's no exchange of electrons in this reaction right here. They just switch places. The electrons don't go anywhere. They don't switch elements. It's that the partners switch. So there you go. And then there was another thing on the list over here. Look for polyatomic ions that have been broken down because they usually contain an element that has been oxidized or reduced. Look for polyatomic ions, which are groups of atoms. So let's look. Well, there's a polyatomic ion there, phosphate. It didn't get broken apart. That's not a redox reaction. I don't see any polyatomic ions in this one. I see that thing fall to pieces. Like, that's a big chunk. Something's got to happen to take that one apart. And you got your free element there too. ClO3, that's a polyatomic ion. That's called chlorate. And that breaks apart into chlorine and oxygen gas. So there's an exchange there. Now this is making a polyatomic ion. This is kind of, well, that's not really a polyatomic ion, but it's complicated. These guys are pretty straightforward. So, and there you have it. I hope that helped you guys out with this thing. And that was my first movie here with my paintbrush and my notes and my kitchen. So take care, guys. If you guys have any questions, email me. We'll get good at this.